Hi and welcome back. Today we're going to be working on the basic Rosehead nail. The Rosehead nail is the image that comes to mind anytime people talk about how blacksmiths used to make nails. It's your basic square shank nail. It has a large head and it tapers to a point. In this video I'm going to be showing you the system of 4 headers that I use to create everything from 1/2 inch tacks to 4-inch spikes. I number the headers 1 to 4, and it just happened to work out that the numbers correspond to the largest nail that each header makes. So I'll use header number 1 for nails that are up to 1 inch long. The second header is used for nails that are larger than 1 inch up to 2 inches long. 3 is used for nails that are larger than 2 inches up to 3 inches long. And finally 4 is used for nails that are larger than 3 inches up to 4 inches long. The headers are made of tool steel and they're welded to mild steel handles. I've tempered them to a light straw so that they can withstand the abuse of constant hammering. So this is the header ready for drifting. I have the round tool steel blank welded to the 1/2 inch mild steel square bar that's going to make up the handle. And I've drilled the header with the correct size pilot hole for the header that I'm making. The countersink on the underside can be drilled any size. I'm just trying to reduce some of the thickness of the header so I'm not trying to drift such a big block. Here you see a chalk mark that I've placed on the drift. This chalk mark locates the exact size that I need at the top of the header. To find that exact spot on the drift, I need to set up a pair of dividers that I can use to measure the exact length that drift sticks out past the top of the header. I set it up while it's cold and I use the dividers when the work is hot. Drifting the hole to size is a 2-step process. First you drive the drift in with a few light hammer blows. And then before the drift heats up too much, you take the whole thing over to the vise and you knock the nail header off of the drift. And then it's the same process over and over again until you've worked the hole to the right size. At this point I'll do all the grinding and sanding that I want to do to get the header to its final shape, and then I'll put it through a heat treat. I'll draw it to a light straw color. The PDF file that accompanies this video gives you all the information you're going to need to set up and use the headers. It's important to use the right size pilot hole for the header that you're making. This will allow you to drift the hole in as few heats as possible. Each nail header is designed to be used with a specific size bar stock. Unfortunately, the number 1 header uses a bar stock that just isn't available around here, so I've had to resort to recycling common nails for this header. Header 2 and 3 are close enough in size that I can use 1/4 inch round bar, and number 4 uses 5/16 round bar. These are all readily available, so that isn't a problem. To use the nails, I had to make special tongs that would be able to work around the head of the nail. This allows me to use the nails right out of the box. I don't have to cut the heads off before putting them into a regular pair of flat bit tongs. The tongs are easy to make. They're just regular flat bit tongs that have an extra piece of metal welded to the inside of the jaws to create the offset to work around the nail head. I pre-drill the bar before welding it into the jaws, and then when I have everything ground to shape the way I want, I separate the 2 jaws by sawing along that drill line. The other modification I made is the addition of a small foot on one of the handles. This allows the tongs to stand vertically, and the weight of the other handle is enough to hold the nail in the forge. I generally make nails in a propane forge, so I've made 2 pairs of tongs so one nail rod can be heating up while I'm working on the other. These nail headers need to be kept well oiled. I think the gradual taper of this type of nail just makes them susceptible to locking themselves tightly into a nail header, and a little bit of oil just prevents that from happening. Small nails should be forged on an anvil that's 8 to 10 inches higher than your normal forging anvil. The process of forging any nail is the same. You start by pointing the bar and then creating a shoulder that defines how much material you're going to use for the nail. And then you use however many heats you need to draw that material out until it fits into the header. While it is true that some nails can be made in 1 or 2 heats, that certainly isn't the standard. Most nails take several heats if you don't want them looking like little miniature splitting wedges. So my approach is just do what you have to do to get the job done right. If that involves using a few extra heats, then that's fine. Just don't drive yourself crazy living up to some hypothetical standard that may not even apply to what you're doing. Next, the nail needs to be cut from the bar. This is normally done with a Hardy tool, but I find it easier to use a modified pair of bolt cutters. I clamp the bolt cutters in a vise, and the gap that I've ground into the jaw prevents the nail from getting cut all the way through. The hardest part of nail making is centering the head of the nail over the shaft. Once the nail is in the header, it cools very quickly, so you really only have a couple of hammer blows to get that head centered in the header. If you don't get it in the right position, there isn't anything you're going to be able to do to move it over once it's gone to a black heat. The rest of the nail head can be forged cold, and I usually forge the 4 facets on the top of a rosehead nail with a series of light hammer blows. The nails made in header number 1 offer a unique challenge when you're trying to get them out of the header. First of all, the points on these nails are so fine that you really can't hammer on them without distorting them. And quite often these nails don't stick out much through the base of the header. So the only way that I've been able to figure out how to work around not being able to drive the nail back up through the header is to pry them from the top of the header. I use a screwdriver that is ground with a very fine knife edge, and I drive that underneath the nail head to pry it up. A couple of light hammer blows is usually all it takes to pop the nail free. I also make sure that I dip the nail header in the oil bucket after each nail so it offers no resistance and I don't distort the head trying to get it out.